I think let me share with the context, but I hope everyone is aware of the context already. Yeah, so a few days back, Lee actually created this issue which says that adds support for service mesh patterns in linker adapter. The same is actually true for every adapter other than Istio, because Istio has basically almost 100% support for doing things via patterns as well as mesh ops. We'll see what exactly the difference is in those kind of things. So the idea is that every adapter right now is capable of performing some operations, but it performs those operations via RPC called mesh ops. But the same operations can be performed via patterns also. And in order to do that, we have a function called we have a function called process OAM. This process OAM is I may be able to show where exactly this function comes from, but the idea is that when on the remote side, Meshery, whenever it sees that there is something which needs to which is a pattern and should be invoked on any adapter, it will invoke this RPC. This is an RPC. It's defined on. It should be defined on every other adapter. Right now, it's available only on Istio. That's the issue. That is, this should be actually replicated everywhere. The internals of this RPC won't be exactly same, but the basic concept, the basic idea would remain same. The concept is that this process OM RPC, which should be attached to handlers. If you would actually look into the adapters, you would see that, for example, this is Istio adapter. Istio adapter is kind of embedding this adapter struct. This adapter struct comes from Meshery adapter library. So in every adapter, you would see similar structures, similar structs, and you will have to add method called process OM to that struct. So that's what is being done. We have created our method and have attached it to Istio struct. Now, what this method is going to get via RPC, the first thing is context. This actually is being implemented by the gRPC client. And the second thing is actually OM request. This is something actually today, Ravinder was also basically asking that what exactly is this thing. So what you get in this here is a username, delete op, and OM comps and OM config. Username is would be dependent. So this is basically user ID of the user who is invoking the operation. This can be used to track who actually invoked the operation. The second is delete op. If what in patterns, if someone has observed, there are two kind of operations that can happen. One is provisioning something, and another is basically deprovisioning, removing that thing. So if delete op is set to true, we will actually act in revert. That is, whatever we have provisioned via that pattern file, we will attempt to unprovision, deprovision that thing. The third is OM comps. We'll see what OM comps exactly is. It is represented as an array, as a slice of string. The reason is that gRPC is strict on basically it's strict on the structure. So what we do is because OM comps structure change very frequently, it will actually depend on the type of OM comp it is. So because the structure changes very frequently, so what we do is we convert it into JSON and then we package it in a slice and then we send it. Same as OM config. This is actually also is supposed to be a struct, but we send it as a JSON. That's where the structure is looking at string. So this is I was just clearing it up because I think Navindu had this question. Now what we do on the yeah.
Question, if I could, question. So understanding the history around the provisioning operation and the delete operation. All right, I understand that. Moving forward, so a separate support for an update operation. That's
actually the thing is that right now every pattern operation automatically supports update. By automatic, that's really absurd term, but by automatic I basically mean that if you have used a pattern file already to provision something. So for example, if you have used a pattern file for provisioning Istio on a certain namespace, and if you do apply again, that is you set a delete op to false, that is you want to provision something, and if the operations see that the entity that you're trying to create already exists, then it will actually update that thing. It will, right now, every operation supports that, be it an adapter, be it in server. If you are applying more than once the same pattern, it will convert it into update thing. Uniquely identifying is a different criteria. Some of the things can be namespace, some of the things cannot be may not be namespace. So it will identify that depending on the object that we're talking about. But the basic idea is that if you are applying the same pattern file over and over again, the next time it's actually, instead of trying to provision it again, it will try to update it. That's an undocumented thing that these operations do actually. Needs to be documented.
So yeah, so the update operation is implicitly supported by a provisioning operation, and they can be, the system is smart enough to make that one and the same.
Yeah, right now it is. Right now every operation figures out if it needs to update or create.
Nice.
So moving on. I'm going in detail of what this process OM function actually does, so that we cover the contribution side. If we have some time, we can go that how the entire flow works. But because I think this is the most relevant part for the contribution stuff, so let's cover this thing first. So what we have covered so far is that we are going to get some OM comps and OM config, which we have no idea right now what it is. We'll see that later. So what we are trying to do here is we feed the OM comps that we have received, all the slice of string, and we convert into OM component. What exactly it looks like is here. You would actually, the spec has updated. It's on version 0.3.0 right now. What this particular OM components and OM config, these actually follow version 0.1.1 v1 alpha 1. This is basically we are not up to date with the spec as of now. We comply with version 0.1.0. So if you would switch to that branch, you would be able to see this particular file, which describes that how application components should look like. This is exactly what you will get here. This function is exactly doing that, parse application component. And the application component that was sent from the remote side, that is Meshery, is actually now converted into a struct. So yeah, the basic idea is that we just convert it into an array of v1 alpha 1 dot component. How it exactly is supposed to look like is defined here. What you will get in here is basically this. That is, you define some workload definition and trait definition. Okay, now I'm supposed to explain what workload and traits are. We'll keep it for later. But the thing is that in here you get some component definitions and config definitions, as we talked about. The component definitions will have names like this. That is what we have defined in JSON. So right now, this is the resource that we're talking about is istiomesh. Its name is istiomesh. This is exactly what would be present here in comp.spec.name. That's what you are going to get. So I'm mentioning this because we will encounter it in some other function. This is not very relevant part. We are just extracting out the component definitions and config definitions. Let's see how exactly we handle them. Now this is the handle components function. It takes in the array of component and is it a delete operation or not? And then if we see that component.spec.type, as I was saying, the spec.type will have the name that is specified here. It is ensured that these names are not mismatched by Meshery server. So we can pretty much guarantee that if this name, if it is being matched here, basically every time it will be matched, it will be valid. And you do not have to perform any kind of validations on this end, because every validation was performed on the Meshery server side. So it's pretty much guaranteed that everything that's coming in here is 100% validated for now. So what we check is if the component type is istio-mesh, then we can just go on and try to provision an istio service mesh. And if we see that the type is virtual service, we try to provision virtual service. If we see if it's none of them, then we actually try to go and handle the istio add-ons. this comes with inherent assumption that there are two specific kind of workloads. One is Istio mesh, one is virtual service, and the rest of them are actually add-ons. Obviously, if one of the thing is not add-on, then we will create an if block just like this, because this is the recent one. You can see it was created a week ago. So moving on, if you have figured out that the type of workload is Istio mesh, then you can actually try to handle that workload. Now,
sorry for interrupting.
Yeah.
So that pattern OAM function, that it didn't look like it had anything Istio specific to me. Can you go back to it? Pattern OAM, handle components, and yeah, and before this also there's one function you referred, right? Process OAM or something.
This one.
Yes. This just correct me if I'm wrong. There is nothing Istio specific in this.
Yeah, actually it gets Istio specific a bit later on. So the thing is that this process OAM, this is just a RPC. This RPC would be available and should be available in every adapter. This is just a way for Meshery server to communicate all of the relevant information, that is application components and application configuration, those kind of things. Even Meshery server to some extent does not know what those things are, because it isn't supposed to exactly know that what those things are. It's the adapter which is supposed to handle those kind of workloads. So process OAM is definitely not very Istio specific, not very linker specific. It's by design, it's not very specific. But when we come into the details that what process OAM is exactly doing, so you would see that here this handle component Istio mesh. Yeah, this is where it starts getting specific to Istio service mesh. So you would see that here I'm trying to actually basically I'm trying to extract version from settings, and then I'm even basically casting it to string. I should have checked if the casting is right or not, basically by doing something like this. I didn't, because I know that it is supposed to be string. It is going to be string. The reason I know so is because in Istio mesh definition, in Istio mesh JSON schema, this is something that we can really talk about. I have already specified, this is something that actually we registered to Meshery server, that hey, if you are sending me anything, please do verify it against the JSON schemas that I'm providing. So because I have provided that version is supposed to be string, I can just do this. I can cast it to string. So this is where actually it starts getting very specific to Istio. So you can see I'm extracting out that what version the user has specified. I take it and then I proceed to install it. This function is actually already defined. This is the basic idea. That is, we have most of the functions already defined in adapters. All what we need to do is to convert it from OAM thing to the thing that the adapter already understands. So so far we have seen that all this function's responsibility is that it's going to get an application component definition. It's supposed to extract out the stuff that it needs. In this case, it's version, and then it proceeds to call the older function that it already had. And that so we haven't seen how install Istio works, because we do not actually. We may have to, but in this case, we do not have to. This was a functionality that was already available in the adapter, and that's what exactly is happening. That is, we are just kind of mapping application component into the stuff that adapter already knows. This is true for the Istio provisioning stuff, but may not be true for other things. For example, if you would see virtual service is very specific concept of Istio. At least I'm not aware if someone else also uses virtual service. But it's a very specific concept to Istio. And if you would see here, there is no function here we already had a function called install Istio, because this functionality was already available in the adapter. But configuring virtual service, that's not a functionality that was available in adapter. So here we get a bit specific to virtual service. What we do is we create something that looks like virtual service. And then we actually extract the stuff that we may need from application component, like component.name annotations. This is actually a kind of I think this is documented. Yeah, we are not supposed to touch the annotations and labels, because we do not own it. The adapters do not own it. Only Meshery does. Meshery can place any annotation, any labels, so that it can keep track of the object. So we just take in the stuff that we need. We pass in the stuff that Meshery server has asked us to pass, and then we actually take another thing that we may have needed, and that is this com.spec.settings. How this is exactly going to look like, you can actually see it in here. This is very huge because this was configured on the flat, but we are pretty much sure that this thing is going to comply the JSON schema that we have provided, because Meshery ensures that once we have that, we convert into YAML and then just apply the manifest. This is example of functionality which was not present in the adapter, and it's very specific to the patterns. Only patterns have access to it for now. You cannot invoke this particular operation via meshops operation, which we already had. It's a RPC that we already had. So if you would have seen the UI, you can basically call a lot of operations via the UI. Those happens via meshops RPC. This is not a functionality that's exposed here. This is very specific to patterns. So the idea is, as you were saying, that process OM is not specific to Istio, but the internals of process OM do get specific to Istio or every other adapter that may be implementing it. So handle MTLS, this is very specific. Okay, this is specific to MTLS in this case, but not that MTLS is only supported by Istio. I hope you got the idea.
Yes, and the JSON schema you were referring to, they are influenced, like they're decided by that OAM ka guidelines, right?
No, so the JSON schema. So the thing that is determined by the OM spec is this. That is the definition. So you would see that it says core.om.div v1 alpha 1. This is the one that we are following right now, and this is actually influenced completely by the spec. However, the JSON schema, we refer the JSON schema here. That is, hey, the definition refer is actually here, and you would see that this is what we are calling. So this JSON schema, this is not controlled, not governed by the OM spec. This is completely up to us, provided that you are using schema version, draft 07, draft 8, and draft 4. These are the 4 JSON schema versions that Meshery supports right now. If you would provide anything else, it will throw error actually. It won't register your things. So these are things that are not governed by the adapter. Sorry, by the OM spec. However, this thing is, they are very interrelated to the extent that they are even registered together. So you can see that we are referring the same file in here, and this is what Meshery would actually use to figure out that where the JSON schema is, so that it can actually verify your pattern file against it.
All right, thanks. It's sounding a bit better now.
Okay.
Couple questions if I could. So Service Mesh Performance, that project has a proto that specifies the names of things that we recognize as service meshes. And I don't know if that use of that proto has found its way into the adapters or not. It should have. Abhishek, yeah. Abhishek is actually a good one for you to speak to if you can.
So can you repeat it again?
Okay. Are we using SMP protos here in adapters for things like? Oh, wait, I think I have a stuck key on my keyboard. Sorry. Say it again. We are.
We are using it for adapter names.
Okay. Okay, good. And then, so do you know, can we reference that? Is that a constant that we are able to define and then just reference that instead of Istio? Like in this case, like the more that we look to propagate this set of functionality, the more ideally it is copy pasta. Like ideally, even if it's specific areas, we have to go swap out the name. Even that would be nice if it's just consistent, like there's no name swapping.
Okay, here, yeah, got it.
So food
ideally it has to be reused.
Same thing in the message is like, oh, hey, this isn't of type such and such. So just, I'll take some notes. Let me get out my red pen. Hold on. And then, okay, second question is, well, there may not be the answer that I'm hoping for, but so if the component, the spec type for a given component that we're interacting with is of type virtual service, that's unique, it's special, we need some consideration for it. Brainstorm aloud with me. Is there any way that we can not have a long collection of if statements? Like, is there any way that some of these considerations are like that this can be more dynamic, that like, is there a particular attribute of a component, of the virtual service component in this case, that needs to be handled in such a way that like any other component with that same attribute we would treat in the same way? And so it's not an if the type is virtual service, it's more like if the type has this attribute, then, you know, like, can we make this more generic? Is there any way to avoid?
So are these types pattern specific or Kubernetes specific?
No, it's pattern specific. So these names can be anything that we define here.
Okay, so we can create a collection of them, like a set of strings, and then basically we can see if they are a part of those. Like for example, when are these registered?
When are these?
Registered, as in when do you
Yeah,
identify that
when the
type
adapter boots
virtual
up.
service? Okay, so like basically you're telling the adapter that type virtual service is valid. So when do you do that?
When we tell the adapter that type virtual service is valid.
Yeah, so basically, let's say for example, HTTP mesh virtual service and more that are out there. Is it possible that we can statically have it in a config and kind of compare in this follow? Like for example, if that set of configs is, let's say, types, then we can say that if this particular type is present in the types, then we can do the following.
But the thing is that probably we can, but still, because the Istio mesh installation is Istio mesh specific, and so is virtual service. So the thing is that we still have to invoke different functions in that case. The reason is that the internals, the internals of each object, each service, each workload gets a bit different. So in this case, we have something called version under settings, but we do not have a version in here. So the thing is that we have to extract out we may have to extract out different things in different type of workloads. That's why we have different functions, and basically that's where it starts diverging. So if you would see that we have a single function for Istio add-ons, because all of the add-ons have actually the same kind of need. That is, all of the add-ons are guaranteed that they will have same kind of settings. So we can kind of put them under the same umbrella, and we can operate similarly. But just some of the things,
yeah. So in that case, we can like basically map the type with a function. Like we can store it as a config with the combination of a type being mapped to a function.
Okay. Yeah, we can do that. Basically, a map, basically a map we create where the type is we have virtual service, and that is mapped to this particular function. Basically, then this thing supposedly will shorten up, because all we will do is substitute the type that we get from here into that map, and whatever function it returns, we just invoke that. Is that right?
Yeah, the type would be the key, and it'll automatically give you
Yeah.
the, like, it'll automatically invoke the function.
Yeah, that should be. Yeah.
And so, yeah, we don't, so Utkarsh, just to put myself in your shoes, we don't necessarily have to agree to either these two topics, at least on this call right now. Just because you know, it may take some contemplation, it may take a little bit of reflection to the goal of both of the questions is in a lot of respects like, how do we make the vast majority of the support for pattern files, the code of it, like consistent? Well, we're trying to make it ubiquitous, and as we go to do that, to facilitate both making it ubiquitous and of high quality, that it would just be extremely consistent. Like it would be to what you had said earlier, is like really the only changes that Navendu and Aditi and others that are contributing might put in are like, it's fairly well highlighted, like, hey, it's over in this map of custom resource names or something like that. Like it's, and, or it's, or, you know, it's in various areas, but it's pretty, it's a little bit of a different requirement than what you were, you know, your primary goal in creating it in the first place. So sort of now as a secondary reflection, it's like, okay, hey, how do we make most of this as generic as possible? Yeah. Like it's some of it's just stuff like, well, and I don't know, again, like think this is just stuff to think on. I don't know that these are the right suggestions, but it's like on line 7, line 7, but it's like handle component Istio add-on. It's like, well, maybe it's just a generic service mesh add-on. Are we, because the others have similar type things. You can, for Linkerd, you can enable, disable, or like, anyway, it's if you reflect, if you put on those goggles and look at your code through that perspective after the fact, maybe some of it becomes more generic. Maybe it makes it harder to understand, and maybe that's not worth it. You know, I don't, which is just.
So we can definitely do what Abhishek was saying. The reason that we would be able to do that, because that's almost what we have here. It's just that, yeah, it will be more concise. The thing that we may not be able to do is to have just one function which handles every type. The reason is the same that I was specifying. That is basically every workload has different kind of schema, so we may not be able to pass it out generically. So that's something we may not be able to do that.
Makes sense.
So I think we are pretty much done here. This actually we were talking about all the while we were talking about the components, application components. So just like we have OM components, we also have OM configuration. We may be able to go how they differ and what they are, but I'm not sure if you have time for that. But yeah, so the thing is that just like OM components were, we have OM configuration. The differences, primary difference is that was a slice. This is not a slice, because the thing is that Meshery server the first thing is that Meshery server is pretty smart. It figures out that these 3 workloads or these n number of workloads share same configuration. So what it will do is it will create OM components, 3 OM components. It will pack it, and it will create a configuration which is being applied on 3 of them. So that is why actually configuration is always 1 and components are n number. So Meshery server is smart in the sense that it will basically create the right configuration and right components and pack it up and send to the right adapter. And this also complies with the OM spec. OM spec also demands the same. That is, there can be a number of application component, but should be only one application configuration, at least till 0.1.0. So that's the only reason that we have this as non-slice and that was slice. If someone was wondering that, why is the disparity? But yeah, so here the thing is that just the same concept that we had, that is, we are looping through the components. So the thing is that application configuration, if someone is interested, can definitely look at the spec. Basically, in order to go in detail at how exactly application configuration looks like and what exact thing it may or may not have. But the basic idea is that application configuration has an array of components, and in all of those components there is traits defined. Let me show a pattern that will make it more helpful. So the thing is that we have something called traits in pattern files. So one trait is called MTLS, and the trait is called automatic sidecar injection. These traits are in parallel to the OM traits. So if someone is going to look at the OM spec after the session, then they may be able to draw some parallels. So the thing is that we have something called traits in there. These are exactly same as OM traits. So this is what we are trying to extract in here. That is, we loop through every component. We see, for example, istio-mesh, and so we encounter istio-mesh, and then we see if istio-mesh has a trait called MTLS. If it does, if its name is MTLS, then we actually do the thing. Basically, we handle MTLS. If it has a trait called automatic sidecar injection, then we actually handle automatic sidecar injection. Now, again, these two are under the ifs because the way that they are supposed to be handled is a bit different. So you can see that in case of MTLS, we actually specify the policy, which is not the case for automatic sidecar injection. In automatic sidecar injection, we basically just handle the, we label the namespaces. That's what exactly happens. So you say in here that, hey, enable automatic sidecar injection for these namespaces. So that's what we are doing. We get the namespace that you have specified in there under traits.properties. You cannot see properties in here because that's something that happens automatically. But that's the basic idea, that we extract the namespaces from there. We cast it to something. And then we call the handle namespace label, because actually automatic sidecar injection in case of istio is nothing but adding label to the namespace resource. So that's what we're doing. That's why they are being handled differently. So the basic concept or basic idea behind both of the function is pretty much same, and that is that we take in the configuration in format of OM, in format of what OM spec actually defines, and then we just map it to something that adapters already know. If I hope that made sense. If someone has any questions so far. If anything confused, because we have some time left. So. No. So I think that's pretty much it. That is, yeah.
We can just for myself, which is that. Well, you may have brought it up, but can you bring up a handle in MTLS function? Has that changed for service mesh patterns, or is that the exact same as it was?
Yeah, it's the exact same actually. It reuses the apply policy function that we already had in Istio. That hasn't changed yet.
Okay. Now, all right. I'm going to ask this question. We can bring it back up later if it is easier to answer later. But you had referred to these two paths, two types of operations, one being that of mesh ops, meaning sort of the current generation of service mesh operations that are supported by adapters today. And then the pattern ops, or if I can use that phrase, for the way in which, we're looking at now. So you can answer this later, but the question is around, like, do they become one and the same, or do they perpetually stay separate, or does one go away displaced by the other? Or
so actually process OM can displace the mesh ops because process OM is more flexible. Basically, it is flexible because we specify the OM config as string, and ohm comps as string. So basically, we can package anything that we want to. We can convey the adapter, and then it can process the way it needs. It wants to. The thing is that Meshops is kind of restricted as far as I understand. That is, it has some RPCs. It can use those RPCs. Definitely, it has has the advantage. Basically, the flexibility comes in that it can specify n number of operations under a category, but the thing is that they are binary operations, like they can be on or off, or what they can be is basically um, they can apply a custom manifest. So the thing the reason I'm advocating for process OM is basically it's more flexible. It can package anything that it want to convey to the adapters. So probably process OM can displace Meshops, because even today, at least in ST adapter, process OM can do everything that Meshops can, except applying custom manifest, because that's not yet available in patterns, but definitely it can be also added.
Thanks, that makes sense. Yeah, sounds like we're on a journey to potential an evolution of mesh ops, of the current form of operations, that eventually we would anticipate those will be displaced by, that those would all eventually perpetually be invoked or displaced or invoked, depending on, by pattern ops, by the process ohm. The reason that I say that's kind of tentative is like the way that there are mesh ops as they are today are put to bed, I think, is when the gRPC operation message type mesh op is either in fact an invocation of process ohm, or it's deprecated such that that message type is no longer, supported. And so does that make sense in terms of how the future might unfold? Like how it might get?
Yeah. Yep. Okay, so I think that's pretty much it for contributing. I mean, yeah, that's the basic idea. That's process
I
OM
have
as a,
one question.
yeah.
Like, could you give us a walkthrough on how the process OAM RPC call is made on the Meshery server side? Like,
I couldn't actually understand. I mean, your voice was breaking a bit for me, at least.
wait,
He put it in chat.
Oh. And now do I access that? Oh, I was missing one of the words. All of the chats. Yep. Let's see this.
So just for Aditi, who might be watching this later, or anyone else who's watching it, that Navendi was asking, can you show how the process ohm is called from Meshery server? So how the ohm components and ohm config are being passed from Meshery server to the adapters. So.
Okay. Yeah. So let me start showing where exactly gets called. We can maybe move backwards. So this is the place where where a process OM actually, the RPC process OM actually gets called. So the things that we were actually showing on that side, the STO side, that the same things are actually available here also. That is, we have a username, we have delete of, if the operation was of type delete, we are passing the OM comms. This is already of type slice of string, and we are passing the OM config as string. Where did this come from? The entire flow actually is not very complicated. It's just that we have a parent file handler. This parent file handler is supposed to get a parent YAML. We read it, we create a parent file. This is just parsing behind the scenes. Not exactly, it does parsing, but it actually it does some extra checks also. Then we create a plan of execution. It takes in something called policies. This was being used earlier. Basically, it just adds. So if you would imagine plan as a graph, it adds additional edges into this graph so that we can enforce a few things on the pattern itself. So, for example, if you are trying to create a pattern where you're trying to provision Istio, Grafana, and Prometheus, so just by doing this, what you can actually enforce is if the user hasn't defined that Grafana should be provisioned after Prometheus, it will enforce that automatically. It can enforce that automatically. This is not being used in anywhere right now. It was being used. So here you can see it's empty. Now this plan is basically just a graph, and now we check for the feasibility of the plan. So here, basically, what we check if there are cycles in there or not. You can actually check the implementation. It's under models. What is models? Yeah, it is being called OM in my directory because I have an older version of Meshery. Probably, if someone is looking at the master, you may see a directory called patterns, and that's where it has been moved to. So actually, you would see graph.co. This is where the actual cycle detection and those kind of algorithms are written, and these are the unit tests. So you can add more, or maybe I will. So yeah, basically this is feasible function, nothing but detecting cycles as well as some other things. So if we see that the execution of the plan is feasible, we proceed, or else we actually say that invalid pattern execution is infeasible. Now this function create comp config pairs and execute action. As the name suggests, it actually creates a comp config pairs and proceeds to create basically execute the action. So it takes in the plan parent file preference of these are not relevant. So let's see what that is. Create config pairs and execute action. Basically, what it does is it generates the application configuration from the pattern file. You can see the internals of this function, but as the name suggests, it basically takes in the pattern file and will automatically generate the application configuration. This is also this is a struct v1 alpha 1 dot configuration, and then this is the main function which actually performs everything. This is called plan.execute, and this is the internals of this function is not very complex, but what it actually does is the plan is already a graph, but what it will create a parallel graph behind the scenes. What parallel graph is basically all of the nodes are Go routines and they communicate with each other. They also make sure that if one of the dependencies has failed, then all of the further dependencies should feel like a domino. So this execute function has all of the not the magic, but you can see the basic. At least from overview, it looks like it creates a parallel process graph and then it starts traversing. It executes the callback CV that you have given it on every node that it visits. We'll probably if we'll have time, which we may not. We'll see that how that works. But yeah, the basic idea is that on every node, these functions are getting executed. What these functions are doing, these are basically creating a comp config pair. We track that which host we are supposed to call at the end, basically at the end of the processing that we have done on a particular node. We'll create application configuration. We do some further validations. This is where we actually validate JSON schema and those kind of things. And once we have done all of the validation, we actually create the entire pair, that is comp config pair, and then we finally call the handle comp config pair action. So this is how OM comps get generated. That is this is where application component got generated. This is where configuration got generated, and then we finally, when we are done making sure that JSON schema is being validated, all of the traits are being validated. Actually, there are some of the restrictions are being put by the OM specs. For example, you have to specify in the definition files like these, not these, trait one. In the traits, you have to actually specify that if you are specifying a trait, then what workloads that trait is valid to. So if someone actually takes up, okay, why did I close it? So here we are specifying traits called MTLS and automatic sidecar injection, but you cannot specify MTLS trait under here. The reason is that you have specified in MTLS definition that, hey, this trait is specific, can be applied only to Istio mesh, and that is also a validation that we perform here. This is also one of the validation that we perform here. Once we have validated that, validated traits, validated the workloads, then we actually finally call the handle config pair action. This is where actually, this is not a very special function. This is not very intelligent. What all it does is basically it converts it the component that we have already generated so far and the configuration into JSON config, and then it just calls the execute action function that we saw earlier. That is, it calls the RPC with the information that we have provided it. I hope that made sense. Actually, this is a hack. I placed this hack because adapters used to at least crash when the operations were too quick. So what I did as a hack was I put the process to sleep. That is, there would be 10 microseconds. The process would sleep for 10 microseconds. I think this is fixed now, so we can probably remove this. But earlier there was an issue that adapter used to just crash because they cannot handle the actions so frequently, so quickly. So that's the entire processing overview. Is that Meshery receives a pattern file, it creates a plan, it checks the feasibility. Once it has checked the feasibility, it starts executing all of them parallelly. It also checks the validation, creates the pairs, and then finally invoke the RPC. And then the rest is handled by the adapters. One other thing that the execute function does is that you can actually, if you return an error from the RPC, execute action will make sure that it captures that error, it packs it well, and sends it back. At the same time, it also makes sure that all of the dependencies or gets to know that, hey, one of your dependency, that is one of your parent has failed. Now it's time for you to fail. So all of the child will start failing. So yeah, this is also something that is being handled by the execute function. This one. I hope that all of the process made sense. And I'm not looking at chat.
Yeah. A couple questions in chat. Well, and these are design questions, I guess, but do we have an operation ID yet?
No, not yet.
Okay.
Not in patterns.
Okay. Do we have one in MeshOps?
Yeah.
Okay. And what is that ID?
What do you mean? Like it's a UID.
It's a UID, and that's generated where?
In Meshery.
Oh, okay. Okay. That seems like something we're going to need for pattern ops. Pattern process. And that's in part because we're going to want to build on the messaging notification center. Well, hey, I asked Meshery to do something. Where is it at? Now, actually, as we think about that, and as we look at something like the planner, the use of temporal or the integration of a workload engine, and the notion that it would have IDs for everything that it's invoking, every process that it's running, might be something we would leverage instead of our own ID. It's okay to have multiple, but. So is the username, so anyway, there's that thought. The other thing is the username enough? So the user that invoked the operation, from there, you could derive whether or not they have permission to do that, because they would ultimately, you'd be able to look up what role they have, what infrastructure they're asking this operation to be invoked upon, that's part and parcel to the operation itself, what account or organization they belong to, basically like in the planner itself, before we get to processing, before we actually get to the process ohm function in the adapter, there's probably an insertion point for policy and for authorization, and part of that being authorization. I recognize we don't have that now, but just, another thought here, just to clarify, inside of Meshery server, the host that the RPC is being invoked against, that host in this case is the adapter.
Yep.
Correct. Okay. And the reason, I mean, that seems really obvious, but the reason I'm asking is because the other host, the other infrastructure, so the Kubernetes cluster, the namespace, the rest of it, becomes a point of consideration as we go to support multiple clusters, and that's also in the context. Like if we look at, okay. So by the way, these call types, is that raw adapter, is that mesh ops, and ohm adapter, that's pattern ops?
Yep. Actually, this raw adapter, I forgot completely, but this was, I said that applying custom operation is not supported. Actually, it is. I created it 4 months ago. I forgot about it. So yeah, basically raw adapter is basically being able to apply raw operations, that is, which are not pattern, via pattern files. This ohm adapter is basically the remote ohm adapter operations, and this non-local is basically not non-local. Oh, I have the older version, but you would see that there is another type, non-local, and that is basically the internal operations. That is present in the application one. This is actually the older version, I guess. So it does not have that. But there are 3 call types. One is non-local, the second is raw adapter, third is home adapter. Home adapter is the remote RPCs. Raw adapter is also remote RPCs, but which are the operations which are not facilitated by process OM, but rather the older mesh ops. And non-local is basically the internal calls. That is process OM, but the internal one. I do not have that here, but probably we have here. Not probably, I know it's here.
For an adapter, okay. Yeah, I wonder if, this is, again, is just a forward-thinking thing, is I wonder if we don't need an extension point explicitly defined. Like the adapter itself is basically, the entire thing is an extension point for Meshery. You design behind these RPC interfaces and you can bring an adapter. Now, within an adapter, we haven't discussed much the areas of extensibility with respect to a couple of things. One is extended additional operations that an adapter doesn't natively support, but that a provider could offer. So I don't know what a good example is.
So if Meshery is being provisioned somewhere where the and it is reachable via the public internet. So what can happen is that is basically they can send their capabilities via that to that endpoint, and when actually Meshery would come here. I mean, when this function is being executed, it will see the host, and because that host should be resolvable resolvable via the DNS, it will get resolved, and the call would be actually to somewhere else, completely somewhere else. This can also be a security flaw. That is, hey, anyone can reach out the endpoint, anyone can raise the capabilities and potentially can draw the traffic outside the cluster. But this can also be an extension point. That is, you register the capabilities via the coming through the public internet if you expose Meshery. And now Meshery, Meshery would just look at the host that you have provided in the capabilities, and it will try to invoke RPC on that, provided that you have process OM RPC defined in there.
Yeah. So in many respects, like basically that treats, if you want to bring your own adapter, you can, and you can register your own adapter's capabilities, which is more or less what you were just saying. I think but if you consider that a little more surgically, like if you wanted to provide, because generally the model would be that, well, not always, but generally the model would be that you'd want to have a deployment of a management adapter or a management, like so a Meshery adapter, and have it deployed locally, have it, authorized within your systems or accounted for. And that if, like ideally the extension point would be internal to the existing adapters that remote providers can layer on additional supported operations. That might get into a whole mess of discussion that we don't need to go into now, because it might be, because it might get difficult to the extent that it sounds like if you were to present, you could, on behalf of an adapter, you could register a capability that the adapter didn't explicitly register for itself. A separate entity, a provider, could register a capability on the adapter's behalf, saying that capability is supported by the adapter, not by the remote provider, but by the adapter itself. If that operation fell within the bounds of the currently defined, the currently compiled pattern ops, or even the currently compiled mesh ops, like that would, it seems like you could layer in additional operations that way. The problem is, most of the time, the operation that you're going to want to register probably has its own special considerations that you would need to have, you would ideally have compiled into the adapter. And so good, I think that's a solvable thing. I think it's a little bit of a, like, it'll take some conversations and design and et cetera, and we'll have to figure out if that's something we really want to do, or if you just leave the extension point at the macro level saying, well, remote provider, you're welcome to register your own adapters, and those can bring their own operations. And you can provide the plumbing to invoke the, basically, why don't you just provide an adapter and have the client, the user, spin it up as a separate adapter? Why don't you just fall into the model and not try to do something dynamic externally, et cetera, but more like just provide another adapter and have them spin it up and it'll register its operations just like anything else. It's not as sleek. I mean, the separation of concerns is clear in that model. It's not as, it would be like, for example, with MeshMap, if you went to a whole different UI, great, you could go use MeshMap in a different UI, and it's a very clear separation of, but it's not nearly as slick as just having MeshMap right there, so cool. I don't know that we would right now that we need to give any consideration to that extensibility that I just mentioned. It can be, not unless, when we go give consideration to it, it might be something where we have a catch-all type of operation that could be registered with specifics. So.
Yeah. So that's pretty much it. At least from the contribution thing, we have other things like being able to, like, what the entire flow of the operations is, that how things get registered. I'm not sure if that's something that we would be going into, or should we? I'm not sure.
We'll wait for these guys to dig into a second layer, probably. I mean, that would be my suggestion, is that let them come upon it if needed.
Yep. So yeah, then that's it. I think at least.
So quickly, for the operation ID, the pattern operation ID, is this something that is a no-brainer in terms of like, yes, we should have one of those, and yes, it should just be a UUID from same thing from Meshery, or does that require some discussion?
No, I think as far as I can think, probably Abhishek can correct me, but as far as I can think, this can just be another field in here which states operation ID and is being controlled by Meshery as a single entity. So basically it stamps the the request with some operation ID.
Do we have is there a separate proto for these RPCs, the OHM RPCs?
It's not a separate photo as far as I remember. At least the last I checked, it was not a separate photo. Or is yeah, it's in the same photo. Just like other operations.
Cool. Okay. Abhishek and Navendi, do you guys have anything else for Utkarsh?
Nope, none from my side.
Cool. Utkarsh, it sounds like, it's worth it in your mind, the refactoring to be a little more generic. Okay. Cool. All right. Utkarsh, this has been great. We'll see you on the next one.
Yeah.
Thanks all. Thanks, Utkarsh.
Bye.
Bye.